Welcome back once again. Today we'll be discussing Chapter 5. In Chapter 5, we'll discuss control structures 2, the repetition or looping. In fact, in Chapter 4, we talked about control structures which were conditional or selection control structures. So today is the second part of that one. And I did mention last week as well that the control structures are basically the heart of the programming. You need to learn how to go through repetition in order to read a large amount of data. And there are three control structures pretty popular in C++ and many of the other languages. You'll find similar control structures as well. The first one is the while loop. We'll be spending a lot of time discussing it. For loop and do while loop. The last loop, do while loop, is not extensively used by myself and some of the other developers, and I'll explain that the reason behind it. And the for loop is pretty simple and straightforward if you know exactly number of cycles you have to go through, and it gives you that specific number of iterations. The while loop is the most flexible and most versatile, which allows you to handle any kind of looping mechanism in any situation. We'll talk about very briefly break and continue statements. I personally do not like them because they come from legacy languages, and there are other ways to avoid bugs in our looping mechanism. So the loops are basically repetition allows you to use instead of declaring more and more code or more and more variables and having more of code, you can do repetition. And this can be used for input purposes, for adding things, calculating things such as averages, and with limited number of variables, you can actually repeat cycles many times. For example, in this case, declare a variable for each number, input the numbers, and add the variables together. That's a perfect example. You can do it five times or 5 million times. Create a loop that reads a number into variable and adds into variable that contains the sum of the variables, for example, for summation purposes, or average purposes, or any of the statistical purposes. Now, by looking at the while loop actually has in C++ parentheses open and the expression. Expression is basically your condition. If the condition inside the parentheses is correct or true, then you will execute the statement under the while loop. If the expression is false, then that statement will be ignored. I personally like to use curly braces to show the body of the while loop, and I recommend the same thing. Even if you have one statement, reuse the curly braces. The curly braces allow you to add more statements later on, just in case if you need to expand the while loop usage. So your expression is the decision making or logical expression. That's where either you get true or false, the Boolean expression, and and the statement is part of the body of the loop. That's why I stated that I personally prefer you have a curly brace. And once I go to the demonstration, I'll show it to you. The parentheses are part of the syntax in Java, C++, C Sharp, and C. But if you go to Python, you will not find the parentheses. Instead, you will find the colon at the end. So slight variation. And also, in Python, the indentations indicate that those statements are part of the looping mechanism or part of that structure. In case of C++, Java, C Sharp, and C, we use curly braces to show the body of that particular structure. So if you want to see the flow chart, there is an expression. This expression could be any condition. If the condition is true, do this, run these statements, and stay in this loop as long as the condition or expression is true. At one stage, the condition becomes false and we exit the loop. Of course, we want to make sure that this expression does not become infinite expression. We want to exit at some time because we have limited resources for memory, for time, and also all that other reasons as well. Here's a good example. So here, let's assume that we have integer I equals to 0 and 0 is less than 20. So condition or this expression is true. And then it goes inside, displays the value of 0, and then increment I to 5, from which is 0 plus 5 becomes 5. And the 5 is still less than 20, displays 5. then it becomes 10. 10 is less than 20, displays 10. This becomes 15. 15 is less than 20 or equal to 20, less than or equal to 20, and it displays 15. Then at one stage it becomes 20, and 20 is equal to 20, so that will be displayed as well. And then when it becomes 25, you exit the loop. The variable in this example is called loop control variable. So there are different ways you can control the loop, and it tells us that you want to make sure you do not stay in that loop forever. You want to exit the loops at some time, and that's why the incrementing of that particular variable I equals to I plus 5, or depending on how you want to control that one, you want to have that incrementing value available inside the looping structure. So it is avoided by including statements in loop body that assures the exit is possible. Let's take a look at this one. I equals to 20. Is 20 less than 20? No, the condition is false. So in fact, it never enters the body of this particular loop. All right, let's continue. All right, so when you know exactly how many times the statements need to be executed, we call something called counter control loop. Counter control loop, which we saw earlier, it can be run that many times, 10 times or 100 times. Let's say you have 100 employees and you have to process their paycheck, then counter control loop is perfect for that purpose. But in many cases, we do not know how many times we have to go through the loop. Number of customers, making orders, or certain other things are happening. So we do not know, we do not have the idea how many times we have to go through the loop. So here, this is called sentinel variable or sentinel control loop, which is sentinel variable is tested in the condition. So you ask the user by initializing the value of that particular loop control variable, and it could be a number or it could be character. So here, if that particular variable is not equal to sentinel, sentinel is something which you want to terminate at that time. If that particular variable matches with the sentinel value, you stay in this loop forever. At one stage, this variable is updated and you want to exit. For example, for sake of comparison, let's say the sentinel value is no or n to exit. If this variable does not, oh sorry, yes is to stay in this loop. If this particular variable stays yes, you stay in the body of this loop. And at one stage you give a different character such as no or n, then you exit the loop. And this example is you have to make sure that it is uppercase or lowercase, because upper and lowercase, they actually are different in these programming languages. That's what is being highlighted in the slide. There's another kind of loop is called flag control loop. And a flag control loop allows you to use a Boolean variable to control the flow. So here we can set Boolean found equals to false, and not false is true. So while this one is true, we stay and process the data inside, or we run these statements inside the loop. And then if this expression, if something triggers this expression, and if this expression becomes true, we change the found equals to true. Remember, initially it was false. We change it to true. And then we say not true. Not true means false. Then we exit the loop. So sometimes, and many times, in fact, we control the looping mechanism with this flag control variable. And in this case, it shows the random numbers. There's another one which we'll be using in project number 5 probably, and it is called end of file control while loop. And this end of file, because every file, such as a simple file, text file, has some kind of hidden character which indicates that's the end of file. We like to call it EOF, EOF for end of file. And when we reach that EOF character, or when the EOF character is read from my file variable, then we can actually stop reading the data. So that's another way to run a loop. So you can see the while loop has all sorts of various ways and techniques to you can run a loop, and you can exit. And then another one here shown here is with the C in. Now, this might not be very meaningful example, but as you can see that if you're reading the data, and if the data is a good data, let's say the data is some kind of numeric value, some kind of integer, and then you stay and continue to process it. You continue to add into this particular case, and you read the next data, and the data is a good data. So C in goes stays in a true state or good state. At one stage, if you give a bad data, you give a character, for example, the C in goes to the failed state. When it goes to the failed state, then you do not enter the body of the loop. Again, this is not a good example, but this is how it shows you you can actually control. When C in goes to failed state, you can stop reading the data. In the file, which I'll be demonstrating just in a few minutes, and you can use a special function EOF, and this EOF function always will allow you to see if the end of file has been reached. And then you can also have multiple conditions or multiple expressions. So here number of guesses is less than 5, and if it's not, the number is not guessed correctly, and there's an AND operator in the middle. Both conditions must be true. And it's a good practice to enclose each one of these conditions in a separate set of parentheses. You can see one set of parentheses here and one set of parentheses over here. And then if both conditions are true, as long as these conditions remain true, we stay in this loop. And this is the flexibility of the while loop, like I stated, and it is the best way to check many different types of conditions. Here it uses this example here. I'm going to use my own example just in a bit. And I'm going to skip this example here. And then it shows you how to declare the variables. We have seen those and how to use those variables for that example. So I'll be showing you my example just in a bit. And in fact, the example I will show you that will help you to complete your project as well. And then the next loop is the for loop. The for loop is perfect when we know exactly how many times we have to go through the cycle. If we know there are 5 times we have to go through the cycle or 10 times, for loop is perfect for that purpose. So in for loop looks a little complex, but it's not that hard at all. In fact, you have initial variable, then you check the condition, and then you increment or decrement the variable. So it has 3 parts to it. You have variable declaration, condition, and incrementing the variable. So for loop also actually will stay in that loop as long as the condition remains true. And so it's a looping condition. If this condition is true and the statements are executed, update that particular variable, and then you come back and then check the condition the second time. At one stage, the condition becomes false, you exit the loop. This is a good one here. So here, I don't like the way the author has shown here. It should have integer I equals to 0 right there. So there's no need to declare integer I outside. So I should have int equal I equals to 0 here. And when 0 is initial value for I, 0 is less than 10, or I is less than 10, and then it will display the value of I. And then in this next cycle, I is incremented to 1. 1 is still less than 10, then 1 is displayed. In the second cycle and further cycles, the declaration doesn't happen again. Declaration happens only the first time. So this declaration and initialization of I variable happens on the first cycle. After that, only the incrementing is happening every single time. And that's another example here. It will display hello that number of times, and also it will display the asterisk in that case, and I'll be demonstrating that one. In fact, I will be starting my demonstration with for loop. And this one actually will display, again, you can see that you can have declaration of I and checking the condition and incrementing everything outside of the parentheses. I do not recommend it, although this is legal, it is possible. But that's not the purpose. The purpose is that all of those things, declaration of I and the checking the condition as well as the incrementing happens within the parentheses for loop. So if you want to see how this one is done, I will be more than happy to show you as well. The loop can also go in a reverse order. So if you have start with I with 10, 10 is greater than 1, and then it will be displaying the value of 10, or which is the value of I. Then it will be decrementing to 9, then 8, and at one stage this becomes 0. 0 is not greater or equal to 1. Then you exit the loop. So you can actually do the decrement for loop as well. You don't have to always increment or decrement by 1. You can also increment by 2 or 5 or whatever the logic is. And finally, there's a loop called do while loop. And I personally do not like this loop, and I'll explain that in a bit. The do while loop allows you to enter the body of the loop the first time without checking any conditions. In the first iteration or first cycle, you enter the body, you run all the statements, then you check the condition all the way at the end. And in the next cycle, the second cycle, if the condition is true, then it goes back in the loop, body of the loop. If the condition is false, then you exit the body of the loop. So why I think it's not a better option, because you are entering the body of the loop without checking any conditions. And the author explains that sometimes you have to run at least one cycle. In that case, do while is a better option. But there are ways around it. But I personally don't use do while loop very frequently. And then in the last couple of slides, it shows that statements can become simple or compound. Regardless, whatever it is, we are going to use curly braces for every looping structure. And we did the same thing with if in chapter 4 as well. This one is your basically do while loop cycle. And this is your do while implementation. I equals to 0. Nothing is being checked here. 0 will be displayed. And then I is incremented to 5. 5 is less than 20. The condition is true. Then you go back and display again. So the first time in first cycle, you entered the body of the loop without checking any conditions. Then it compares the while and do while here. Or I actually generally saying while is way, way more powerful and better. And here in this slide, it says, well, all these three loops have their own place in C++. If you can determine in advance how many cycles you have to go through, how many repetitions, the for loop is ideal. I completely agree with that one. And if you do not know and cannot determine in advance the number of repetitions, and it could be 0, use a while loop. Also, if you have multiple conditions you have to check and different types of conditions, then while loop is the most flexible, the best looping option. But if you do not know and cannot determine in advance the number of repetition, but at least one, you have at least one cycle, then do while loop is recommended. There's something called break and continue. I will discourage both of these. These are something we had from 60s and 70s and 80s languages. Break allows you to exit the loop forcefully. We shouldn't be writing the code when we have to absolutely break out from the condition. It should be very seamless and continuous in a fashion. And the continue statement, continue keyword can be used to skipping one cycle. So if you want to skip a cycle for whatever reason, you can use continue. I don't think so. These are good practices, but they are available to you in C++. So continue can be used for while, for, or do while loop. And then by using these loops, for example, if you have two for loops, this runs the 5 times. This over here checks j is less than equal to I, which is the value which is given here. So gradually, initially, the first time it will be displaying 1 character, then 2 characters, then 3 characters, and then it will look like a triangle. You can do the reverse order as well if you start with the larger value, and you can actually you can have a reverse triangle. A piece of code written on top of an existing piece of code. This is called software patch, and some programs address the symptom of the problem by adding a software patch. This is something which we see that debugging is always done and upgrades of software is always done. Use loop variant. In this case, basically telling you that you can use the looping mechanism to check these options for updating the software. So we covered the chapter. Now I will be showing you some of the demonstrations. Let me share my screen with you. Okay, let me try again. All right. Now you can see my screen, and so I'm going to show you the for loop first. So I recommend for parentheses int I equals to 0, I less than 10, I plus plus. All right. Even if we have one statement, I recommend we use curly braces just like that. And I want to display the value of I. So I, and then we can add a space after that one, just like it was shown in the, uh, and then we will have ENDL outside. If you just want to have an extra line at the end, you can do this way as well. All right, when I run up my code, if everything is good, you can see it runs 10 times, 0 through 9. What if I want to start with 1? Sure, you can start with 1, and then you can make it less than equal to. So if I run the code again, now you can see it runs 1 through 10. Traditionally, we always start with 0 because, and by the way, if I leave this one here, less than equal to 10, and I'm starting with 0, it's going to run 11 times. It's going to run 0 through 10, which is 11 cycles. Okay, so you have to be careful with your condition. So for loop is perfect when you know how many cycles you have to go through. So if I want to have, just put an equal sign there, make this one 50. And if I run my code, now you can see, oops, I didn't want to show that one actually. Just to show the equal sign, it looks like a line like this one. And again, for loop can be used for any one of those things. So sometimes you don't have to do I plus plus. You can say I equals to I plus 2. So now when I run my code, let me put I back here just to show you, put a space there. And now you can see, let's just keep it to 10. We don't have to go through that many cycles. Starts with 0, and then it goes 0 to 4, 8. It runs 5 times because of the increment was by 2. But if I want to decrement it, which was demonstrated there as well, you can always say I is greater than 0 and I minus minus. So this time you're decrementing it. All right, let's test it out. So now, oops, we got an infinite loop. Good. You have an indication that it goes forever. It never stops. So why it's happening? So we started I with 10. 10 is greater than 0. And then we said I equals to, and my condition is false. Instead, I should have done this way. I minus minus. So I just had an extra variable which was being assigned at that time. So now you can see started with 10, goes all the way to 1. So you can do all sorts of incrementing or decrementing in your case. So for loop is perfect when you have exact number of cycles and you can have multiple statements here. The second loop, which is the most flexible one, and that's what we're going to use in our class for most of the purposes as well, is the while loop. So while loop, if you remember, we used for so many different types of cycles. So you can have one condition here or multiple conditions here. So I'm going to show you what if I want to use the while loop just like I use the for loop, which is a number of cycles, exact number of cycles. So if I say I less than 10 and I is declared outside right there and 0 is less than 10, that is correct. And I can show the value of I here and add a space there. Then I have to increment I as well. So in the for loop, all these 3 steps were done in one place: the declaration and initialization, the condition checking, and the increment. In case of while loop, because it's not designed for that such a simple purpose, so it is done separately in three different places, but you'll get kind of similar results. As you can see, we had very similar results. Now, what if I have something called a sentinel value? And the sentinel value could be, you can have a char, you can say continue equals, I don't want to confuse you with the variable name, so I'll say value equals yes. So now in this case, I'm going to change my condition here. I will say as long as the value equals yes. So, and then if that's the case, I will display a message just to see. I will say I am inside of the loop. Okay, just to see if it actually works. And because the value is yes the whole time, if I run my loop, it's going to become an infinite loop. Let's run and take a look. It becomes an infinite loop. It's going on and on and on because I had no check over here. So after each cycle, I have to stop the loop first. After each cycle, I will ask the user, I will prompt the user, do you want to continue? And then we can give those options to the user. And then we can capture that answer from the user in that variable called value. All right, so this is better. So now I have that prompt and I will pick up the input from the user. So now when I run my code, after one cycle, it says, do you want to continue? I say, yes, I want to continue. I put lowercase y and it stays in that loop. What if I put uppercase y? If I put uppercase y, it exits the loop. So in that case, you can actually have or operation here or operator here. You can say value could be equals uppercase y as well. If I run my code again, I say yes, uppercase, it stays in the loop. I say lowercase y, it stays in the loop. What if I say yes? In that case, it exits the loop. It doesn't know. So in that case, if you want to say multiple characters, then you have to change that to string data type. So let me just show you that one as well. So string value equals to start with lowercase y and change that to lowercase y. And again, later on, you will learn in string, you can use some string functions called uppercase, lowercase. So if you do so, oops, or value equals, now I can say yes like this as well. Or I can add another one. I can say value equals, yes, lowercase, and on and on. So let's test it out. So this time when I run it, it goes inside the loop one time. I say this time, yes, I want to continue, or lowercase. I need to stop this one and read another code. Sometimes it gets stuck. So I say yes, lowercase, it stays in the loop. I say uppercase yes with the uppercase Y and hit enter, it stays in that loop. I say Y, lowercase, it stays. I say uppercase Y, it stays in that loop. If I say no, it exits the loop. So you can see you can have multiple conditions. And if one of these conditions, because I'm using an or, it stays in the body of the loop. All right, the next item I want to show you, I'm going to exit this particular loop, is EOF, end of file. For end of file, I showed you last time as well. You can add a file by clicking here, and my file is called input.txt. Again, you can name this file anything you like. And in this file, I have some data here. And the data is name of a person. Let's say Mary. Let's say Mary is 19. And let's say Mary's balance is this much. Then we have another person, Joe. Let's say Joe is 21. And this is Joe's balance. And then we have another person. Let's say Jose. So Jose is 18. And this is Jose's balance. All right, so we got three people, we have three records. Notice that this piece of data is string data, this piece of data is integer data, this piece of data is double data type. So we have three records, and all three records, they have different data type. As a developer, you need to know how the data is laid out, how the data is going to be read. If you have no idea how the data is in a database, you will not be able to read the data successfully. So I'm going to read the string first, integer second, and double data type the third. So when I come back to my code, I need to have those declared variables. So I'm going to declare variable, let's call it first name. I'm going to declare a variable, let's say age. I'm going to declare a variable and let's call it balance. Okay, so got three of them. It is a good practice to initialize them, which I discussed last time as well. This is how you can initialize your string. This is how you can initialize your numbers. This is your initialize your real value, so double data type. Now, how do I know how many records are there? Well, I can see manually there are three, but it could be 3,800. It could be some other number. So that's where we are going to open that file first. And if you remember, we learned that one. So we're going to use if stream, and I declare a variable in, open that file, in.open, input.txt. So file is open, so we will have access to the file. Now, in order to use ifstream, I must have a library called fstream included. So we are going to use fstream here, fstream. So that particular library is included. All right, once that's done, then although I cannot see it, but if I try to move down arrow or right arrow, I can't move my cursor because that particular location, that's where end of file exists, EOF. It's a hidden character. I can't see it, but it's there. Now I'm going to ask my while loop, look for the hidden character. If you do not find EOF, stay in this loop forever. And if you find EOF, you can exit. How do I do that? I can say not in dot, and there's a function called EOF in that particular library. And this is my condition. What does it mean? It means I'm looking for EOF. And EOF, because EOF does not exist by itself, it is part of the file, in file, which is I created here, which is connected to input.txt. So I'm saying go to the input.txt. And if you do not, this is not operator, if you do not find end of file, stay in this loop. All right, so what do I do inside here? So I'm going to read the data, and I'm going to read in that specific order. I'm going to read the first name, I'm going to read the age, and I'm going to read the balance in that specific order. Once the data has been read, I'm going to test it out. I'm going to say, okay, if I read the name successfully, show me the name. Let's add a space there. And if I read the age, let's add a space there and show me the balance. After that one, I'll do E and DL. All right, let's test it. Literally, we just had one expression or condition in our while loop, and then we read the data here, and then we are displaying just to verify the data. All right, let's test it. And we successfully picked up all three records, as you can see right there. So our program worked exactly how we expected. This was not possible um, that we ran all the data. And by the way, if you go back to the input file, and if you copy that one a couple of times and change the last person to, um, let's say, Al, and change the value over here to something else, and come back to your code, you don't have to make any changes to the code. And in fact, you run the code again, it's going to pick up every single record, as you can see. And the last person is Al, and we changed Al's record. So my program is so useful that doesn't matter how much data you have in there, either 3 or 3 trillion, it doesn't really matter. It's going to still process the data as expected. So literally we declared the variable, we've opened the file, we read the data, and because of this EOF, we have this ability to do so. Okay. And you will be doing that in project 5 as well. So just, and I have the demo file on our Canvas site as well, just to show you. But if you follow the directions I'm showing you here, you should not have any trouble reading the data from a file. Once the data has been read from the file, you bring it to your code, then you can process it. And the processing should not be hard because we have been working on some projects already. The last kind of loop I want to show you is, if you remember, we saw another type of loop. We saw a loop which was infinite loop. I demonstrated that one to you. Counter control loop, I demonstrated that one to you as well. Sentinel value, when I said yes or no. And then I showed you EOF. One is the last one I want to show you is called a flag control loop. So flag control loop. And again, if you want to comment out certain part of your code, you can always do slash asterisk, asterisk slash. What it does, it will be ignored. So here, I want to declare a flag equals true. Okay, you can declare as false as well. You can declare as true as well. But either way, so then here is my loop. While flag. All right. While flag means as long as flag is true, I will stay in the body of this loop. So when I go inside here, and I'll keep it simple just to demonstrate, I go inside here just to show you that we were able to successfully enter the loop. And then I want to check something over here. I want to say if continue, you want to continue, yes or no. It's kind of similar to the previous demonstration I showed you, but in this case, we are controlling with the flag or Boolean flag. And then I want to ask the user, um, in that case, you know what? We don't have to ask the question honestly. If something happens, uh, let me just change the slight variation here. If something happens here, um, let's say I had some kind of counter here, int count. We started with 0, and every time we went inside, we incremented the count. We incremented the count. Then we check if count equals 5. What I want to do at that time is make my flag false. So hopefully this may make sense to you. So if I don't have this statement, I'm going to have infinite loop because I will have no way to exit it because I'm controlling everything by flag, and flag was initially true. So when the flag is true or expression is true, I go inside and display this, increment this count, and the count will be checked every single time. If the count equals 5s, then change the flag to false. Otherwise, continue to run this loop. Let's check it out. And I go inside 1, 2, 3, 4, 5 times, and after that I exit. I was able to exit because my flag became false after the 5 iterations. Okay, so hopefully this chapter is pretty simple and straightforward, and our project associated with this chapter is also pretty simple and straightforward. I have given you enough knowledge that you can successfully complete this project. All right, I'll see you in next chapter.